in 7-1, we're talking about adding and subtracting polynomials. There's also a lot of just random vocabulary in this section, so we'll talk about all of that as well. So looking at example 1 on page 393, this says determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, binomial, or trinomial. Remember that mono is 1, bi is 2, and tri is 3. These are prefixes that we use to denote those numbers. Okay, so up here, monomial, 1 term, binomial, 2, trinomial, 3. The degree will depend on the exponents. So for example, in this expression, there's 1 exponent here. It's a y to the first power, so the degree of this part is 1. The degree of this term is 1 plus 1, so this one has a degree of 2. The degree of the whole thing would be the biggest, so 2 is the degree of the whole thing. And since there are 2 terms, this is a binomial. So this one is a polynomial and specifically a binomial with a degree of 2. So let's look at the bottom guided practice ones. The first one says x. Okay, x is a polynomial, and specifically it's a monomial. So polynomial, yes. It's a monomial. The second one, it has all just regular exponents and letters, variables. So this one also is a polynomial. And specifically, there are 1, 2, 3, 4 terms, but when we combine these two, -2 plus 4 would give us 2y. So now there are 1, 2, 3 terms finally, so this would be a trinomial. So this one is a trinomial after we simplify by combining the two. This one is also going to be a polynomial because there's just regular exponents and regular letters. So this one is 2 terms, making it a binomial. The last one has a negative exponent here, a -4. That would make it not a polynomial. So this one is not a polynomial. Okay, and if we wanted to know the degree of the polynomials, this one has a degree of 1. So the degree is 1. This one, the highest degree, this term has a degree of 2. This term has a degree of 1, and this term has a degree of 0, so 2 is the highest degree, so 2 would be the whole polynomial. This term has a degree of 1 plus 1, so 2. This term has a degree of 1 plus 1 plus 1, so 3, and so the whole thing would have a degree of 3, and the last one is not a polynomial. Okay, the next set on the next page, we're writing in standard form, which means we want the biggest exponent first, all the way down to the smallest exponent. And then it says identify the leading coefficient. The leading coefficient would be the number, the coefficient in the front of the highest degreed term. Okay, so this one in standard form, the 4 is the biggest exponent. So we would write 4x to the 4th, and we're done with that term. The next highest exponent is squared, so we would put -2x squared, because remember this whole term has the negative included. This one is -3x, and the last is 8, so plus 8 there at the end. All right, and then it says identify the leading coefficient. The leading coefficient would be the 4. 4 is the leading coefficient. This polynomial is a degree of 4. Okay, on this one, putting it in order, we would have the -7y to the 6th first, then the 5y to the 3rd, the -2 y squared, y, and 10. This is in standard form, and it would have a degree of 6. The leading coefficient would be -7. Find each sum and difference. With sums, you're just adding all the like terms together. Because there's a +1 here, if we were to multiply every term in this set of parentheses by a +1, it wouldn't change anything. So all we're doing is we're combining like terms. There's a squared and a squared. 5 minus 3 would give you 2x squared. The -3x and the +6x would give you a +3x. And then 4 and -3 add to give you 1. So here is the sum of this polynomial and this polynomial. The next one, same thing. We have a 4 exponent and another one. 1 minus 2 is -1y to the 4th. The third is the next highest exponent, so we're just gonna put that because there are no like terms with 2y to the 3rd. The next highest exponent would be your 2y and -3y. -3 plus 2 is -3y. Oh, I'm sorry, -1. -1y. But we don't need this 1 at all, so let's just keep it -y. And then 7 and -11 added together would give you a -4. So this is our final answer here. The differences are a little bit different because it's a -1. So we're distributing the -1 to each of the terms in the second set of parentheses. So I would have 4x to the 3rd minus 3x squared plus 6x minus 4. So first set is the same. The second set would change all the signs to the opposite. So this would be plus 2x cubed minus x squared plus 2. And now we combine. This one and this one would give me 6x to the 3rd, -3x squared, and -1x squared is -4x squared. The 6x, and there's no like terms with the 6x, so we're just going to write plus 6x. Then we have the -4 and the +2, so -2. This would be our difference when we subtract the polynomials. Same thing here, we're distributing the -1, which changes all the signs. So we have 8y minus 10 plus 5y squared, but these all change. So -7 plus y cubed minus 12y. And then we combine the like terms. The y cubed has no like terms, so I'm gonna write y cubed. It's the highest exponent. And then I have the 5y. It also has no like terms, so I'm going to just write plus 5y squared. -12y and 8y. If I were to combine those together, I would get -4y. And then I have a -7 and a -10. So -17 would be my last term here. And that's it.